Welcome everyone to our second video of dealing with 2D sprites in Unity 2D projects. So I've got a 2D project set up here, nothing's in the scene right now, but today we're going to explore how we can take the 2D sprites that we looked at last time and animate them. We're going to do this in a couple of different ways. The first thing I'm going to show you is how we import an existing animation. So Robot Boy is something that's already set up to be animated, so we're going to take a look at that. Then we're going to take a look at how we can create our own animations, both in Unity and outside of Unity. This is going to be one of those topics that unfortunately we're going to find, just like with building complex 3D models, other programs are better suited to do this than Unity. So we're going to look at Unity's very simple capability for creating 2D animation, and then we're going to talk about how, if you are artistically inclined, you can create your own animations in a separate program like Photoshop. So let's start by taking a look at an animation that has already been made for us. So we have an animation here. This is in the 2D standard assets that I imported called Robot Boy Idle. And if we look at Robot Boy Idle, it's a very minor animation of him just standing around. This is meant to be the animation that's played while Robot Boy is doing nothing. And it's made up of several, excuse me, it's made up of several what are called keyframes. A keyframe is all the moments in an animation in which the robot or the subject changes. Let's go to walk, because that's a little bit easier to see. If we look at Robot Boy's feet in the walk animation, we can see that each keyframe shows him in a different point during his walk, with the last keyframe being just about where the first keyframe started, so that it makes a loop. Remember that an animation, especially in traditional animation, is nothing more than a series of images, kind of like a flip book. 2D animation in Unity operates the same way, but it uses something called a sprite sheet. Sprite sheets, I'm going to highlight this right here. Sprite sheets are, I did not want to restart my computer, basically flip books of 2D characters. So they're all the frames, keyframes of a 2D character animation, but they're kept on a single page. So if we actually expand this guy, I'm going to go over to our inspector when I click this sprite sheet. We can see that unlike with Iggy in our previous video, the sprite mode is set to multiple as opposed to single. Multiple means that we're saying that even though this is one image, we want this to be considered several separate sprites. And the way that we modify those sprites is by going into the sprite editor. I'm going to add a note for this in our notes here. We can modify sprite sheet frames in the sprite editor. So here we can see what the actual entire image looks like. The actual image file is one file that contains all of these frames of the animation kind of stacked together. And the job of breaking these up into separate frames has already been done for us. So Unity uses a process called slicing, where it takes a single sprite sheet, it slices out all the different sprites, and then it uses those sprites as separate frames, keyframes in an animation. So this one's already been done for us. Let's look at how we get the animation into the scene, and then we'll talk about how to make our own. So the easiest way, in the next video, we're going to talk about how to make more complicated animations through what are called animators, and how to make transitions between animations. But today we're going to talk about the simplest way to get an animation into our game. So if I've got a sprite sheet like this that's all set up with my separate animations, all I have to do is select the starting point, hold Shift, and select the ending point so that all of these guys are highlighted. And then I'm going to drag this guy into my scene. I'll put him like right here. Now, as soon as I do that, Unity is going to try to create something called an ANIM, or animation file. What this does is it's basically a file that holds the instructions for playing the animation. So I'm going to call this robot walk. And I have already created a folder for this. So I'm going to keep this under animations, and I'm going to save it. Now, if we go to the animations folder, Unity has created two files for us. So where is my animation here? Animations have two parts, the animation and the controller. So the animation itself, this guy, holds all of the frames in order so that we know exactly how the animation is supposed to look. Sorry, I think I said that backwards. Yeah, this guy's the animation. I said that backwards. This is the animation. This file contains everything we need to know about the animation itself. The controller is what tells the animation to start and stop. It's also what we're going to use to transition between animations. So when I say, hey, stop walking and start idling, controllers are going to be responsible for that. But for right now, we're not going to worry about transitioning. We're just going to worry about the animation itself. So I've dragged these frames onto the screen, which has created an object. I'm going to make this object more generic. I'm going to call my game object robot. So it makes more sense. And then I'm going to play my game. And like magic, all those frames come together with the help of my animation file and my controller to produce an animation. So that's great, but now what happens if we want to change the animation? Well, there are some issues here. Remember that an animation is nothing more than a collection of images. If I want to change, where is it? This animation, I have to go into a separate file and actually change the image. So doing 2D animation requires us to be a little bit comfortable with image editing and drawing, because it means that if we want to make a change, we have either we or a friend of ours with artistic talent has to go ahead and actually change the sprite sheet. We cannot modify the sprites within Unity. But let's take a look at how we can chop up the sprites ourselves. So in my sprites folder, I have added a sprite called Guitar Sprite. Now, if we look at Guitar Sprite, this is just a sprite sheet I pulled from the internet. I went on Google and I Googled sprite sheet, and this little guitar player is something that came up. So let's take a look at this and split it up into its own frames. Right now, if we look at the sprite mode, it's set to single, meaning that if I expand this sprite sheet, it's not split up into separate sprites. If I drag this guy out here right now, it would think that it's all of these separate images are one sprite, and we don't want that. We want to split this up. So we are going to change this to multiple, and then we're going to hit apply. And now, oh, it looks like it already did it for us, but we're going to look at how that happened. We're going to go into our sprite editor, and we're going to notice that Unity happened to slice this guy up for us. It doesn't always work this well. So I want to show you guys how we can split this up ourselves if we need to. So I'm going to go to Slice, I'm going to go to Automatic Center and hit Slice. When I do that, notice that Unity didn't do a very good job. So I said, basically what I'm telling Unity is, hey, where do you think the sprites are? Do an Automatic Center Slice and cut everything up. And Unity said, well, I see images here, 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 here. So it made sprites from all these different individual stars and images. If I apply this, we can see that my sprites don't end up the way that I want them. I want each of these 6 distinct areas to be sprites, not every individual image. So Unity, unfortunately, didn't do this well automatically. So instead, I'm going to change the slice type to grid by cell count. What that means is I'm going to tell Unity, hey, there are 6 sprites on this page, and then Unity is going to slice up the page into even chunks so that I can have the sprites I want. I'm going to say, hey, column and row. There are 3 columns and 2 rows of sprites here. 3 columns, 1, 2, 3, and 2 rows. Now slice. Now Unity did a much better job. Unity said, okay, if there's 3 columns and 2 rows, then I'm going to evenly divide this sheet into 6 chunks, and it has done that. So now if I apply, I get a much better sprite sheet. I also have the option of doing it by size. So if I knew, for example, that all of my individual sprites were the same size and they are 103 pixels by 89 pixels, this is really useful if you've made the sprite sheet yourself and you know exactly how big your sprites are. Then you can say, all right, this is my new grid. Go ahead. Every pixel is 103 by 89. When you hit slice, it would divide this up into 103 by 89 pixel chunks. Okay. So now let's, just for fun, to make sure that that worked, to show that there's nothing special about the robot boy, I'm going to go ahead and drag this sprite in as well. and it wants another animation. So I'm going to switch to the animations folder, and I'm going to call this animation Guitar Hero. And I'm going to call this game object Guitar Hero. And now let's see what happens when we play. So we end up with both of our animations going. So far, so good. So we've covered the first half of my notes here. We know how to use sprite sheets. We know how to modify the sprite sheets in the sprite editor. And we know that every animation has two parts, the animation and the controller. So what we're going to do now is animate some things ourselves. Even though the best way to animate 2D is to use sprite sheets, we do have some limited capability in Unity for creating our own animations. And we can look at the animations that have been made by Unity as well. So I've gone ahead and imported another of the famous and most popular Nintendo characters, one of the Ice Climbers. And we are going to scale him down a little bit so he's not so gigantic and terrifying. And then we're going to animate him just by using Unity's tools. So notice that Popo is not a separate sprite sheet. He is a single sprite. There's not anything special going on here. What I'm going to do is use Popo's transform values to be able to animate him. So notice that if I change the rotation of Popo, let's do -25, he starts to turn in the forward direction. What I want to do is continue this process so that Popo spins the entire time that he's on screen. I basically want to create an animation that is based off of his transform component. So by creating animations, we can use what are called keyframes. And again, keyframes are moments of change in an animation. We can place keyframes on components. What this means is I can tell Unity, hey, I want you to make keyframes using the rotation value of Popo to be able to create an animation. So to do this, I'm going to do a couple of things. The first thing I'm going to do is I'm going to go to Window, and I'm going to go to Animation somewhere here. Window. I don't think I want Animator. I think I want Animations. I am not seeing it. Window animation. Oh, it's right here. It's right in front of me. My goodness. Okay. I'm also going to move this into the next to the hierarchy view so I can see it better. So it says to begin animating Popo, create an animator and an animation clip. I'm going to hit create. Now notice that this is going to ask us to go through the same process as when we dragged in multiple sprites from a sprite sheet, except this time Unity is controlling the animation. So I'm going to say this is Popo spin, and I'm going to save it. And just like before, if I go to my animation controller, I now have a Popo and Popo spin animation and controller. So now we need to tell Popo what we want him to do. When we start creating an animation of our own, two things pop up in the animation window. The first thing is this timeline over here. This shows us 1 second's worth of animation. So if I I can start at the beginning of the animation. If I press this double arrow over, it goes to 1 second in the animation. So basically, what the timeline is doing is it's showing me where my keyframes are. And I keyframe things by clicking this Add Property button. So the Add Property button allows me to say that I want to keyframe Popo's rotation value. So right now, Popo's rotation value is 0. Notice that when I did that, rotation turned red. That means that this property is being keyframed. Now, for the moment, I haven't placed a second keyframe, so nothing changes. But what I'm going to do is I'm going to go to the end of 1 second, and for those of you that have had 3D art and animation with me, I'm sure this looks very familiar. I'm going to go to the end, 1 second, and I am going to change his Z value to -360. Now it looks like nothing changed, but negative 360 is actually a complete rotation forward. So now, if we play this animation, we should see that he spins. What Unity does between keyframes, so the reason that a keyframe represents a change in animation is because Unity is doing what's called interpolating all of the frames between frame 1 and frame 60. In this case, we have a 60 FPS game, so there's 60 frames in a single second. So frame 1, we're at 0. At frame 60, we are at negative 360 degrees. So in between here, Unity just figures out what the rotation values should be using interpolation. So this thing that you're seeing right now is called the dope sheet. The dope sheet, and again, this is in our vocab here, the dope sheet is a collection of keyframes. You can see that there's a diamond here that represents the keyframe at frame 0, and there's a keyframe here at frame 60. So those diamonds just show us where the keyframes are. They do not, however, show us how the animation occurs. If we want to see the flow of the animation, we need to go to the graph, or actually, I forget, this is Blender terminology, the curve editor. And we do that by going down to curves down here next to dope sheet. If I click curves, we can see that this curve slopes down. So this represents the rotation value at each spot in the timeline. So we can see that as I run across the timeline, Popo is following the curve of this rotation animation. Now, the thing I don't like about this animation is that he pauses. I want him to spin constantly. And we can see why that pause happens. That pause happens because the curve starts out slow, then gradually increases, and then levels off again. For a lot of animations, this is good. This is going to provide natural movement. But we want this animation to continue in both directions. So what we're going to do is we're going to put our timeline back here. We're going to select this keyframe, right-click it, and I am going to say that I want the right tangent. Now again, this is just an example. You guys are going to want to explore with all of these to be able to figure out exactly how to modify your curves. I'm just showing you one example of how we can have a constant looping animation. So I'm going to say I want the right side of this line, this point, to be linear. I want it to be a straight line so that there's no starting and stopping. So I'm going to choose the right tangent to be linear. That's going to make a straight line going straight down. However, it still levels off. So I'm going to go to the end, and I'm going to say, make the left part of this line linear. Now we have a straight, direct linear change in animation. And if I play, then I get an animation that doesn't slow down or stop. And we can see that that's because it's going straight down at a constant rate the entire time that the animation plays. Now, keep in mind that we can pretty much animate anything. So notice that I have the transform, I have the sprite renderer. If I were doing 3D objects and I had color or material, I could animate the material. Pretty much any component that creates a visual change in our object can be animated through this process. But remember that when we deal with 2D animation, we can't actually change the image itself without going and modifying the sprite sheet. So we need to have a little artistic ability and a little photo editing prowess for that to work. In the next lesson, we'll talk about how we can take these guys and change their animations, transition between animations, and use what are called different animation states. Thanks for watching.